All right, we're in section 3.4 where we're going to find and use slopes of lines. So we've probably talked about this in great extent in our intermediate and beginning algebra classes where we first tried to identify slope in XY coordinate planes. Anytime we have a line in a linear equation, we know that it is written in the form of y equals mx plus b. All right, so x and y come from the coordinates that we choose in order to make the line. The values for b comes from the y-intercept, and the value of m is the slope. So we're going to kind of pay attention to that value there. If you look on the bottom right here, we have a formula in order to find slope. All right, to find slope or to find m, we take y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So basically, if once we find 2 points that are on the line, we can figure out what the slope will actually be. Basically, the numerator is the difference of the y values, the denominator is the difference of the x values. If you keep going further, this is going to be vertical change over horizontal change, or more commonly known as rise over run. There are 4 different types of slopes. The first two we should be pretty familiar with. The first two, the one it says is a negative slope. Negative slopes, it says it falls going from left to right. So when we're going this way, and anytime you see a line falling from left to right, so like this is line 1 right here, this would be an example of a line that has a negative slope. And if you see the value of m anytime it has a negative number to it, it would be a negative slope. Same thing, but just the opposite with positive slope. So like this one here, let's call this line 2. It rises as it goes from left to right. And just like with negative slope, if it's a positive slope, the value of the slope will be a positive number. Zero slope is a horizontal line. So line 3 right here is going to represent a zero slope. So it's a horizontal line. So it's in this case, it's going to be y equals some value. In this example here, it's going to be -1, -2, -3, -4. So that would be so you wouldn't have anything as a value of x. And then finally, the undefined slope is a vertical line. It's not a function, so that's why they call it undefined slope. So this line 4 right here it's the example of a vertical line, and when you have a vertical line written as an equation, you won't see the variable y in there. It's just going to be x equals some value, and in this case here it was 1, 2, 3, 4, 5, 6. You know, so we look at those, and that's kind of gives us an idea of what kind of slopes we're going to have for any particular linear equation. So in this particular instance here, it says identify a positive, negative, 0, and undefined slope from 2 points. It says then evaluate slopes of those 4 lines. So in class, we get to choose, or you as the student gets to choose which ones there are. So there are a variety of correct answers, but we were just looking for ones that would make it positive, make it negative, 0, and undefined. So like I could say like let's do the zeros and the undefined. So like I could say like FG right here. This is an example, so I'm sorry, G and H. So like G and H, this would be an example of an undefined slope. For a zero slope, it's any horizontal line. Looks like here, I would say CG. So CG would be an example of a zero slope. I would look at, looks like BD would be a positive, and we'll say in this case AE is negative. Now they're asking for which line is steeper, which means which has the greatest value for slope, um, whether it's positive or negative. So whatever uh, absolute value that you have has the largest number to it. So it either had to be the positive or the negative slope, and that would figure out which line is steeper. Okay. Uh, Other lines that we can take a look at that have ties in with characteristics to slopes are parallel lines and perpendicular lines. When you're dealing with parallel lines, the thing that you have to pay attention to is, are the slopes the same? So you're going to look at, this is a situation where you have to find out if the slope's the same. If m in both equations are equal, then you're going to have a situation where you have two lines that are parallel. When you have a situation where the lines are perpendicular, which means by definition it has a 90-degree angle that intersects the two lines, there is a relationship with the slope there as well. This relationship means that they have opposite reciprocals. And opposite reciprocals, in a more informal definition, is basically you're going to flip the fraction and then change the sign. So example with that would be, say you had line 1 and it had a slope of 4. For it to be perpendicular, line 2 would have to have a slope of, so you're going to flip the fraction, so you'd have to pretend like this is 4 over 1, so it'd be 1/4, and then you change the sign. Since the first one was positive, this would be negative. So for two lines that have perpendicular slopes, they must be opposite reciprocals of each other. Now, we can graph a line through a given point with a given slope. That's something that we can do, just because all you're going to do is this. The first thing you're going to do is you're going to plot the point that they give you. So here, point P is -4, 0. So I just go -1, -2, -3, -4, and it's 0. So you just plot it there. It's right on the x-axis. The next thing you have to take a look at is the slope. So the slope is 5/2. So the value on the top determines whether you go up or whether you go down. Okay. If it's positive, you go up. If it's negative, you go down. In this particular instance, it's positive, so we're going to go up. For the bottom one, this is like our run value. So we're going to go left or right. So if it's positive, we're going to go right. If it's negative, we're going to go left. So in this case, we're going to go up with the numerator and to the right with the denominator. So from the point you just plotted, that -4, 0, that's where you're going to make another point with relationships to the slope. So we're going to go up 5 units, 1, 2, 3, 4, 5, and then to the right 2 units. And then basically, by definition, 2 lines, 2 points make a line, so we can connect those points. Okay? Same thing we have to do for the second part. We got 3, 0, and right here, plot that point. Then we look at the slope here, it's -3/4. We have a situation where in the numerator it's negative, so that means we're going to go down 1, 2, 3 units, and then we're going to go to the right 1, 2, 3, 4 units. And then again, you just connect the points. Okay? If you need more examples, right here it says find the unknown coordinates. So the line through the points has a given slope. So we have point negative 7 comma negative 4, and we have a slope of 1/3, but we have this point Q where it's x comma 0, so we don't know what that x value is. Now, since we have the graph here, so let's plot the point. So I'm going to plot -7 comma -4. Looks like it's right about, excuse me, right about there. And the slope is 1/3. So what you can do is you can keep going with the slope of up 1 to the right 3, 1, 2, 3, plot that point. Well, my y value is not 0, so I have to keep going. So I'm going to go up 1 to the right 3 until my y value becomes 0. So it's not quite. I'm at -2, up 1 to the right 3, 1, 2, 3. And I'm at -1, I'm almost there, so up 1 to the right 3, 1, 2, 3. And now I found it. So that coordinate there is 1, 2, 3, 4, 5. So that means that x is going to be 5. Okay. I look over here, I got a point of 5 comma 3. Let me erase this. 5 comma 3, 1, 2, 3, 4, 5, up 3, 1, 2, 3. Plot that point. And I have a slope of -1 comma 2. And they're telling me that my x value is -1, so -1 is right here. So I have to find my slope, and I have to make a point that's along that blue line right there. So I go down 1 to the right 2. Well, that's not going to work. So it's just as easy to go up 1 to the left 2. That means the same thing. As you can tell, the lines would connect. Up 1 to the left 2, up 1 to the left 2. And now I've gotten to that line. Let's see here. So it's -1 comma 1, 2, 3, 4, 5, 6. So y is going to be 6. Okay. Final thing to do, you're going to see this in your homework. You're going to see these on tests and quizzes. It's asking you to tell whether the lines through the given point are parallel, perpendicular, or neither. So essentially what we're going to do, we're going to use the slope formula that was given to us on the first page, that m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Solve for each line and then determine if they're the same, then it's parallel. If they're opposite reciprocals of each other, then it's perpendicular. If it's neither one of those characteristics, then it's neither. So let's look at example A. So I have line 1 here. I'm just going to say this is my x1, this is my y1, x2, y2. Plug it into the formula. So it's going to be m equals 4 minus 0 divided by 7 minus 1. And then we just subtract both the numerators and the denominators. 4 minus 0 is 4. 7 minus 1 is 6. I can reduce this. I can divide both sides by 2, so this gives me 2/3. So line 2, same deal. I'm going to plug it in to the slope formula. I get 6 minus 0 all over 3 minus 7. So I got 6 on the top, and I got what, like -4 on the bottom. And I can reduce that to become -3/2. Are they opposite reciprocals of each other? Yes, they are, because if you were to flip 2/3, you'd get 3/2, and they're opposites, so these two lines are perpendicular. Now let's look at the last one. So I got line 1 here. Find the slope. So I'm going to go 7 minus 3 all over -10 minus a -9. On the bottom is a situation where we cross the line, change the sign. 7 minus 3 is 4. -10 plus 9 is -1. So now I got this -4 as my slope. If we look at line 2, we got m equals, this is going to give me 14 minus 2 all over 3 minus 6, just plug it in the formula. Finally, I got 14 minus 2, which is 12, 3 minus 6, which is what, negative 3, and 12 divided by negative 3 is going to give me negative 4. They're the same value. So since they're the same value, they have the same slope, this is a situation where these two lines are parallel. Okay? And that is being able to find and use slopes of lines. Hope this helps. Until next time.